Hello, everyone. Welcome to our Splunk Threat Research release for December of 2021, where we will be talking about Remcos. I am Michael Haig. I'm a senior threat researcher here at Splunk, and I am also with Teoderic Contreras, who is also a senior threat researcher on the team. Our job as the Splunk Threat Research team is to study threats. And what we do with that is we take it and we simulate that behavior. We create data sets with it, which we share under the attack data repository on GitHub. From there, we will help build detections that will help our customers and help the community to understand that particular threat. We release different tools, and all of this is shared with the community so that everyone can benefit from our work. So for this particular release, we'll be focusing on Remcos and Windows scripting languages, whether JScript or VBScript. Teoderic will do a deep dive into the Remcos loader, which we analyzed for this release. And then we'll switch over to looking at how we developed or what we developed for our security content on this release. So quick, short story of Remcos. Remcos is a remote access Trojan, particular type of malware. It's pretty much used similar to other type of rats in the wild today. This sample that we analyze here, which Teoderic will dig a little bit deeper into, this is the second stage where Remcos will contact out to a paste type site, download a script, and then from there it loads up what we found as dynamic wrapper X and loads its shellcode, spawns like a helper process, and it injects itself from there. So we found this to be really interesting, and that's why we wanted to highlight it. We released 2 additional blogs before this related to Remcos, and we've released multiple types of different content to help detect Remcos within your organization, within your environment. And so this just finishes it off by capturing the loader portion that we'll be discussing. So now I will pass this over to Teoderic, where he will dive into the loader itself and highlight different parts of that.
The first BBS script is the stager or downloader of the main Remcos loader. This script will try to download a script saved in pastebin website, as we can see here, using XML HTTP object. And by using that object, it managed to open it and then get the response from that one and then execute it. Unfortunately, this URL link was already inaccessible as of now, but we managed to download the main loader that was saved in pastebin during our analysis. And it was saved here as stage 2 Remcos loader.bbs. This stage 2 BBS script is the actual Remcos loader that contains several ways to bypass detection and hide its code from analysts or normal user. One interesting part that we notice is it pad or append some normal script comments from a coming from a normal Microsoft script known as pubprn.bbs, like this one, and also the prnctl comment prnctl.bbs, that's also a known BBS script of Microsoft. Those scripts are designed to publish printers within Active Directory domain services. And as you skim down to this normal code, the malicious code is in between of those normal script code, which is this one. This loader has 3 important parts. The first one is the Remcos agent DLL, which is encoded in this part. The dynamic wrapper X.dll, which will be used to load another modules like kernel32.dll to parse API that it needed to execute the shell code, which is this one. The shellcode is the responsible for loading the Remcos agent.dll to the winhelp32.exe process that will execute and inject the Remcos agent DLL to that one. The next interesting part is how it execute dynamic wrapper x.dll. It is uses regsbr.exe silent install parameter, and also you can see here that it uses virtual alloc and call window proc, which is API it uses to allocate space for the Remcos agent DLL, and also this one to execute the shellcode that will execute the Remcos agent DLL or inject Remcos agent DLL to the winhelp32.exe. The more interesting part is this one, where if it is a x64 architecture based host machine, it will execute the script using wscript.exe process with this unique parameter. Usually wscript.exe is process used to execute JavaScript, but in this case it will execute bbscript. So now let's run this malware loader. Here you can see that the wscript.exe is loading now the winhelp32.exe. And as we read the code of this loader, it should drop the dynamic wrap x.dll in temp folder. So let's see. Here, we can see that it was already dropped here. And now we will try to develop some detection for those notable behavior of this loader to detect it in a possible compromise host. So let's see.
All right, thank you, Tia Derek. So from there, I'm going to move on over to the detection development side. I'm going to showcase a bit into the content that we created and talk a little bit more about that. Okay, so for this demo, I'm going to walk through a bit of the content that we created for this particular sample that we had identified. And so to begin, following like Tia Derek's deep dive into what it's actually doing, what's in the VVS. Now we're flipping to Splunk. We're going to showcase a couple of the analytics that we created. So in particular, we focused a little bit on dynamic wrapper X, and this particular detection on the screen here is looking for event code 7, which is image load from Sysmon. And I added in here 3 things that this will look for, mainly because what if it's renamed, what if it's moved, or what path is this coming from, and what if it gets recompiled? Anything's possible. So as you can see here, the query is looking for dynwrapx, original file name, and the product. And all of these show up based on just executing this particular sample. You get the process name that loaded it. All this is excellent. So now we have good context. And from there, we wrote another piece of content that was, hey, what wrote dynamic wrapper X to disk? And so this particular query is a join, and it's joining the processes and file system endpoint data model. And it's going to tell us here that wscript wrote dynwrapx to disk. And that's the context that we need, right? So excellent information. We have dynamic wrapper X mostly covered here. Now, what about other behaviors? So this particular query is looking for wscript launching with the VB script on the command line. And so what we get here is we executed 2 different samples in our sandbox here. The first sample will spawn winhelp32, and the second sample is executing or spawning CMMON32. So both are kind of similar, but they're spawning a different child process. And these are all spawning off of W script. So it's kind of fishy at this point. What are these, non-standard child processes? Where are they coming from and why? And so we know based on the deep dive that it's loading these to execute dynamic wrapper X. And you can see here, another child process of W script is regserve32 with that silent I, the silent and the install, the switches for dynwrap X, the DLL. And so then another one that we created was particularly looking for suspicious child processes coming off of W script. Now this is a good one to tune for your environment based on what you see. In this particular case, in our sandbox, it's going to catch all these very highly suspect W script spawning win help, and obviously the more hard-coded ones that we put in our list here. But you can add and modify and change as you see fit. And we always provide filters. So if you want to filter out anything in particular that's very common in your environment, go ahead and shoot for that. Another one here, this is the install and the silent switch. So again, looking at the parent process, the command line and what it is that it's spawning. So W script spawning regserve, and you see it's loading up dynwrap X in there. And then I wanted to just show a little bit, like kind of quickly, what CMon 32, WinHelp 32, just kind of like the very fast one-off queries. When you're hunting through this data, I'm just saying, show me everything with sysmon, anything related to CMMon 32. I mostly just was trying to validate that this was the only process spawning it in my environment. So I just said, show me the parent and the command line of the process so I can see if there's any other behaviors in my organization or whatnot. It's just a good way to kind of go through and understand if anybody's using these particular binaries or not. And then another one, just to kind of do quick one-off type queries. You want to hunt through dynwrap X is typically just dynwrapx.dll. You can just type that in, and the way with Splunk works is, drop that in and see what kind of shows up from there. And you can flip by source, or event ID if you're wanting to kind of run through the different ones. But in this case, just mostly it's all image loads. So hopefully that showcases a little bit of the content that we created for this. There's definitely a lot more, but these are the very highlights of the content that we did create. And the focus of this was really on dynwrap X and catching a lot of the very generic behavior. So thanks for listening. All right. Now that we wrapped up our demos, I'm going to wrap this up by talking about the different types of content we created. So we had shipped 26 analytics in total, just related to Remcos. So there's a full analytics story out there. You can get it from our research.splunk.com Remcos analytics story. You'll see all the content there, everything related to Remcos that we've shipped over the last 3 different releases, and the other blogs and whatnot are all there. Hope that you were able to find this content extremely useful, very valuable information. Everything here is available, all the analytics, and obviously if you see anything or have any questions, definitely reach out to the team and I. You can hit us up on our GitHub issues. We also have our Splunk Slack resource and or the Splunk communities page where you can leave comments and discuss with us there as well. Thank you again for joining, and we will see you soon.